Okay, what I would like to talk about now is function inverses. Okay, a function inverse is the undo of another function. So, thinking in simple terms, if you were asked to add something, the inverse would be subtracting something. Okay. Um, so anyway, we're going to start with these steps would be replace f of x equals with y equals, switch x and y, solve for y, replace y equals with f inverse of x equals. So we're going to start with f of x equals 6x minus 10. Okay, so here we go. Do f of x equals 6x minus 10. Step 1, replace f of x equals with y equals. Okay? Step 2, switch x and y. So this is now going to be x equals 6y minus 10. Okay? Switch x and y, solve for y. So switch. Okay, now we're going to solve for y. All right, so I'm going to add 10 to both sides. And I'll have x plus 10 equals 6y. All right, I'll go ahead and switch the sides here. 6y equals x plus 10. Okay, switch sides. You don't have to, but I will anyway. Switch sides. So 6y equals x plus 10. Here we got the 6, divide off the 6. So y equals x plus 10 over 6. The final step is to replace y equals with f inverse of x equals x plus 10 over 6. All right, B. I'm going to plug x equals 7 into f of x. So that's going to be 6 times 7 minus 10. That gives me 42 minus 10, which is 32. I will now take x equals 32 into f inverse of x. So that's going to be 32 plus 10 over 6. And I end up with 42 over 6, which is 7. I came full circle. I start with x equals 7, I got 7 back. Okay? The next thing I want to do is I want to use x equals 8. So, x equals 8 into f inverse of x. So that's going to be 8 plus 10 over 6, which is 18 over 6, which is 3. So now I will plug x equals 3 into f of x. Okay? So I want to know if 6 times 3 minus 10 would give me back the x equals 8. And 18 minus 10 gives me 8. So when I plugged x equals 8 into f inverse of x and then back into f of x, I got 8 back. So these are undos of each other. You plug 7 into f of x, you got the, and then back into the inverse, you got the original back. If I plug 8 into the inverse, take the result and plug it into the original function, I still get 8 back. These are undos of each other. If I plug something into this, take the result and plug it into that, I'm going to get the original number back. If I plug a number into that, take the result and plug it into that, I'm going to get the original number back. Okay? All right. Okay, I went ahead and left the inverse of example 1 on the board and how I found the steps. I moved it to make room for more examples. We are not typically going to be asked to illustrate the functions are inverses of each other. I just wanted to illustrate what the whole idea meant. So this is the inverse for the first example. Example 2 is find inverse of g of x equals x cubed plus 9. All right? So that's the second example I was planning to do. All right, so here goes. Do y equals x cubed plus 9. We switch x and y, so that's going to be x equals y cubed plus 9. All right? Now, I'm trying to solve for y here, so I will be subtracting the 9. And I end up with x minus 9 equals y cubed. Again, I'm going to choose to switch the sides. I switch sides, so that's going to be y cubed equals x minus 9. Okay? If I want to get y by its lonesome when it's raised to the third power, I need to take the cube root of both sides. This leaves me y equals the cube root of x minus 9. And since it was g of x, it's now g inverse of x. That's it. I'm done. All right? Example 3. If f of x equals 2 over x minus, what did I have? 7. 2 over x minus 7. Find inverse. Okay, well, I'll find the inverse. So that's going to be do y equals 2 over x minus 7. Again, we're going to switch x and y, so it's going to be x equals 2 over y minus 7. The LCD is y minus 7. So I'll multiply x by y minus 7 and 2 over y minus 7 times y minus 7. So those cancel, clearing my fractions, and I end up with xy minus 7x equals 2. And remember, folks, I'm trying to solve for y. So I'm going to add the 7x back. I'm going to want in descending order, so xy will equal 7x plus 2. And then the last step is to divide off the x. So I do that to both sides. The x's cancel, and y equals 7x plus 2 over x. So the function inverse, f inverse of x, is 7x plus 2 over x. Example 4 will be my last. Okay? In an effort to ensure that the screen is as likely to focus on it as it should, I'm going to move the computer over. Example 4, or the camera should focus on it, I'm hoping it will. I got f of x equals x minus 23 to the 5th plus 17. Okay? Since the camera has a tendency to go out of focus here on the edge, I'm going to write that bigger. F of x equals quantity x minus 23 to the 5th plus 17. All right, so do y equals x minus 23 to the 5th plus 17. Remember that we will be needing to switch x and y. So now I will have x equals y minus 23 to the fifth plus 17. Okay? Don't multiply that out. We do want to get the y by its lonesome, so we're going to get the parentheses by their lonesome. That will be our priority. So I will subtract the 17 from both sides. So x minus 17 equals y minus 23 to the fifth. I'm going to switch sides. So y minus 23 to the fifth will equal x minus 17. All right. Next step, I want to get the y term by its lonesome. So this whole big thing is being raised to the fifth power. So I'm going to take the fifth root. So I'm taking the fifth root. So I got y minus 23 to the fifth, and I'm taking the fifth root of it. So that gives me the fifth root of x minus 17 as well. Okay? So taking the fifth root of this to the fifth leaves me just the y minus 23. And over here I will have the fifth root of x minus 17. Okay? Next, I need to add the 23 back to get the y by its lonesome. So y equals the fifth root of x minus 17 plus 23. The 23 is not included in the writing. The final step is to replace y with f inverse. Okay? So I have f inverse of x equals the fifth root of x minus 17 plus 23. And ladies and gentlemen, I'm done.